Hello, how are you all? I am going to explain conservation of momentum, which is lesson 6.2 in your textbook. The objectives of the lesson are here. The first objective, we are going to describe the interaction between two objects in terms of the change in momentum of each object. The second objective, we have to know to compare the total momentum of two objects before and after they interact. And finally, we have to know how to state the law of conservation of momentum and how to find final velocities of objects after collisions, given that initial velocities, force, and time are available. Okay? So if two masses are interacting with each other, two objects are hitting each other, an object, many impulses, like, for example, jumping, catching, hitting, we have to talk after impulse and before impulse. And you know impulse from the previous lesson that we took before. So what we are going to understand at the end of this session is that the total momentum of all objects is going to be before the impulse is going to be equal to the total momentum of all objects after the impulse. This is what do we mean by law of conservation of momentum. So let's start, and at the end we will go back to these objectives in order to see if we understood or not. Okay. So conservation of momentum. Suppose two masses M1 and M2, two billiard balls, for example, are going towards each other. M1 with V1 initial, M2 with V2 initial. Okay, I will consider that initial will be like before impulse, and we will consider from now on final is to be like after the impulse. So if the two masses are going towards each other, one with V1 initial and the other with V2 initial, after they collide, after they hit each other, okay, they may bounce, one of them may come to rest and the other will move, or they may move together in one direction. Anyway, in all cases, they both will have V1 final and V2 final. Okay, M1 will go in a velocity of V1 final and M2 with a velocity of V2 final, which is going to be the velocity of M2 after the impulse, and here the velocity of M1 after the impulse. So the law of conservation of momentum is saying that the total momentum before impulse, remember the symbol of momentum that we took before impulse is going to be equal to the total momentum, okay, after the impulse. Total momentum, what is the momentum? Remember, momentum was, the equation of momentum was mass times velocity. And we had two masses, so in this case, the total momentum is going to be M1 times V1 initial, this is the momentum of the first mass, plus M2 times V2 initial, which is the momentum of the second mass. So here we are getting the total momentum before the impulse is equal to the total momentum after the impulse, which is the momentum of the first mass after the impulse, which is going to be M1 times V1 final, plus the total momentum after the impulse, which is going to be M2 times V2 final. Okay? But you have to know also that the momentum of each mass is not necessarily conserved. Yani M1 V1 initial is not necessarily equal to M1 V1 final, and M2 V2 initial not necessarily equal to M2 V2 final. Based on what did we take in conservation of energy? Remember, in conservation of energy, there were kinetic energy and potential energy. But the mechanical energy was conserved, which is the sum of kinetic and potential. So sometimes kinetic may increase, potential has to decrease in order to get the sum to stay the same. Yani, remember kinetic energy, let's say 300 joules, potential energy 200 joules. So the sum is 500 joules, which will stay constant if no friction. Then if the kinetic energy increased to become 400 joules, potential energy has to decrease to become 100 joules, and vice versa. So here the same thing. M1 V1 initial may increase, and so M1 M2 V2 initial will decrease like this, okay? So that the sum stay the same. So I may get like M1 V1 initial to be like 2, M2 V2 initial maybe 7, so 2 plus 7 is 9 here. I may get M1 V1 final to be 1 and M2 V2 final to be 8, but still the sum is 9. So it is not necessary for M1 V1 initial to equal M1 V1 final and M2 V2 initial to equal to M2 V2 final. This is the first point. Second point, if the impulse starts from rest, يعني like two skaters pushing away each other, they were at rest and they push away each other, like a fisherman in a boat and he jumps out of the boat. So initially everything was at rest. A person is standing on a raft on the surface of water and he jumps out, steps out. So what does this mean? Initially everything was 0. So I can put here 0 for everything initial because everything was stationary. So then 0 is equal to 2 is going to equal M1 V1 final plus M2 V2 final. So if I take M1 V1 final to the other side, I will get minus M1 V1 final equal M2 V2 final, which means one will go in one direction, the other has to go in the opposite direction for sure, so that the sum of them has to equal to 0 again, and then so 0 has to equal to 0 since conservation of momentum. We said this. Okay. Now more than that, now if the two masses move together after the impulse, one more point, if the two masses move together after the impulse, sometimes like fisherman jumps into the boat. The boat was stationary and a fisherman jumps into the boat, so they go together. A truck is moving, hit a small car in front of it and take it a little bit and move together for a given time. So in this case, M1 V1 initial plus M2 V2 initial, this is the case of initial momentum, is going to equal then M1 plus M2 together. So the two masses are moving together with one single final velocity after the impulse. So after the impulse, both masses are going with one single final velocity, so it is not necessary to write V1 final, V2 final. Okay, let's keep only one factor. And also you have to know that the momentum lost by one mass is gained by the other mass. A billiard ball, the cue ball is moving, hit a ball which is at rest. The cue ball may come to rest, and so the other ball has to go. Why? Because the momentum of one mass is gained by the other mass. Okay, a ball is moving of larger mass and moving faster than a smaller mass and slower one. Okay, when the larger one hit the small one, okay, the small one will go faster and the velocity of the large one will decrease. Why? Because momentum lost by one is gained by the other. Conservation of momentum leads to Newton's third law. You have to know also that conservation of momentum leads to Newton's third law. Remember Newton's third law that we took, I think, in the beginning of this year. Newton's third law was saying that for every action there is an equal and opposite reaction. Force of mass A on mass B is equal to force of mass B and on mass A, but in opposite direction. Or force of mass 1 on mass 2, yani F12 is going to equal to the force of mass 2 on mass 1, F2 on 1, but opposite in direction. So let's see how conservation of momentum leads to Newton's third law. Conservation of momentum, which is here, M1 V1 initial plus M2 V2 initial equal M1 V1 final plus M2 V2 final. Let me take M1 V1 final to the side of M1 V1 initial and take M2 V2 initial to the side of M2 V2 final. What I will get here M1 V1 initial minus M1 V1 final is equal to M2 V2 final minus M2 V2 initial. But remember that we took impulse before, and impulse was equal to mv final minus mv initial. So here m2 v2 final minus m2 v2 initial is going to be I2, impulse 2, isn't it? mv final minus mv initial 2, so I2. But here it has to be m1 v1 final minus m1 v1 initial. Okay, but here we get the opposite, initial minus final. So it is negative I1. Okay, it is the impulse I1 has to be mv final minus mv initial. It is the opposite, so I put minus here. Okay, so then the impulse of one mass is equal to the impulse of the second mass, but opposite. So remember, there was another equation for the impulse, which was force times the time interval. So I1 is like F1 times the time interval, and I2 F2 times the time interval. The impulse will happen in the same time interval, so we can cancel the time interval. So we are going to get minus F1 on 2 is equal to F2 on 1, which is Newton's third law. So starting from conservation of momentum, I can reach Newton's third law. Now let's have an example on conservation of momentum, which is sample problem page 200. Let me go to the book and show you. Okay, we are here. This is our lesson, conservation of momentum. It is in page 197, as I told you. Here is an example, مثلا 2 billiard balls, mass A and mass B are going towards each other, hit each other, and then they bounce. Okay, here there is a table to show you that the total momentum is conserved. The numerical example, numerical application to see that momentum before is equal to momentum after. Okay, if you count here, you multiply m1 v1 initial plus m2 v2 initial, you will see that it is equal to m1 v1 final plus m2 v2 final. You see here ball A, let's say m1, okay? And this before collision, yani here, let's say v1 initial is 4.5. So mass times velocity, I get 0.72. Ball B, so which is m2, 0.16. It was at rest, so its velocity is 0. The momentum, 0 times anything is 0. So the total momentum is going to be m1 v1 initial, which is this much, 0.72, plus m2 v2 initial, which is 0. So we are going to get 0.72. Here, again, m1, but this is going to be v1 final, for example. So the momentum is this times this, m1 times v1 initial, I will get 0.018. And here, this is the v2 final, multiply, okay? So I will get 0.70. If you add 0.018 plus 0.070, you are going to get 0.72 again. So this is a numerical example to see that the total momentum is conserved. Here is our equation, which is, remember, m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. And let's come to the sample problem. Here, what we were saying about, if everything starts from rest. So here, like two persons push away each other. If everything starts from rest, then for sure we are going to get minus m1 v1 final is equal to m2 v2 final, which means the two objects have to go in opposite directions. Now, in order to reach the sample problem, which is going to be in page 200. A 76 kilogram boater initially at rest. So this is going to be M1. Initially at rest, initially we said yani before the impulse. So V1 initial is 0. Initially at rest, a 76 kilogram boater initially at rest in a stationary 45 kilogram boat. So this is going to be M2, and the boat is M2 and it is stationary. And also V2 initial is 0. So everything in the beginning is at rest. So V1 initial, V2 initial are 0. So M1 76 kilogram, M2 45 kilogram. V1 initial is 0, V2 initial is also 0. Okay, what is the impulse here? The boater steps out of the boat and onto the dock. Okay, so if the boater moves out of the boat with a velocity of 2.5 meter per second, okay, the boater is moving with 2.5 meter per second, and we denote the boater to be M1, so this is going to be V1 final. So V1 final is 2.5 meter per second to the right. Remember, momentum and impulse are vector quantities, so direction is important. So to the right means positive. And we are going to find what is the final velocity of the boat, so we are going to find V2 final. What we are going to do, M1 V1 initial plus M2 V2 initial equal M1 V1 final plus M2 V2 final, but here everything in the beginning has to be 0. So if I take this to the other side, as if minus M1 V1 final is going to equal M2 V2 final. Let me show you. Okay, so we are here. So M1 is 76 kilogram, V1 initial is 0, M2 45 kilogram, V2 initial is also 0. We said V1 final is going to be 2.5 meter per second. How much is V2 final? So we said we can start like minus M1 V1 final is equal to M2 V2 final. So minus 76 times 2.5 is equal to 45 times V2 final, which is unknown. So to get V2 final, divide by 45 both sides. So here 45 with 45 is going to be cancelled. Okay. So then I will get V2 final to be like minus 4.2 meter per second. Then we are going to take the practice, which is in page 201. Here, the practice in page 201. This practice, question 1, question 2, 3, and 4. Let me explain them quickly. Take the given and I will give you the answers so that you can do them yourself. A 63 kilogram astronaut, this is what M1, is on a spacewalk when the tether line to the shuttle breaks. The astronaut is able to throw a spare 10 kilogram oxygen tank. So M1 63 kilogram, M2 10 kilogram. But everything was at rest. Why? We can get it from here. They are saying here, assuming that the astronaut starts from rest and the astronaut was holding the tank. So what does this mean? Okay, so as if the oxygen tank and the astronaut are both at rest in the beginning. Now, when he throws the oxygen tank, okay, in a direction away from the shuttle with a speed of 12 meters per second, propelling the astronaut back to the shuttle. So when he throws the tank, he has or she has to go in the opposite direction. So assuming the astronaut starts from rest, so everything starts from rest with respect to the shuttle, find the astronaut's final speed. So we call the astronauts to be M1. So as if we are going to find V1 final, okay? With respect to the shuttle after the tank is thrown. Yani, let me come back. M1 63 kilogram, M2 10 kilogram, everything initially is 0. So I have to use minus M1 V1 final equal M2 V2 final. But here what is given is V2 final. Why? The tank, okay, is going away with a speed of 12 meters per second. And we call the tank to be 10 kilogram. The 10 kilogram to be M2. So since the tank is M2, then here this is V2 final. Before throwing, after throwing. Before throwing, everything was 0. After throwing, the speed of the tank, which is M2, is going to be 12 meters per second. So this is going to be V2 final. So the question is to find V1 final. Let's see. Okay, here, so M1 is 63 kilogram, V1 initial is 0, M2 10 kilogram, V2 initial is 0. V2 final is given 12 meter per second. You are going to find V1 final. The answer here is written in red for you. It is about minus 1.9 meter per second. But please, you have to do the calculation. Now, question 2. An 85 kilogram fisherman jumps from a dock into a 135 kilogram rowboat at rest. An 85 kilogram is M1. 135 kilogram rowboat is M2, but it is at rest, so V2 initial is 0. Now M1, which is the fisherman, is jumping on the west side of the dock if the velocity of the fisherman is 4.3 meter per second. So V1 initial is 4.3 meter per second to the west. So it is negative 4.3 meter per second. So now V2 initial is 0, but V1 initial is available. It is minus 4.3 meter per second. What is the final velocity of the fisherman and the boat? Yani now the fisherman and the boat will go together with the same velocity. So as if we are going to have one single final velocity. What does this mean? I have to use the equation, which is M1 V1 initial plus M2 V2 initial is going to equal M1 plus M2 together times one single V final to be calculated. So let's come back here. M1 is 85 kilogram, M2 is 135 kilogram, V1 initial minus 4.3, V2 initial is 0, and you are going to find one single V final, which is going to be minus 1.66 meter per second. And what else? Question number 3. Each cricket ball in a set has a mass of 0.5 kilogram. Now here, the mass is the same. Yani the green ball, let me call it M1, it is 0.5 kilogram, moving with 12 meter per second. So this is V1 initial. Strikes the blue ball, it is also 0.5 kilogram. So M2 is 0.5 kilogram, but it is at rest. Yani V2 initial is 0. Assuming that the balls slide on a frictionless surface and all collisions are head-on, find the final speed of the blue ball in each of the following situations. First situation, part A. Okay, I have to find the speed, the final speed of the blue ball. Yani I have to find V2 final. But what about V1 final? Here, part A, if the green ball stops moving after it strikes the blue ball. Yani if V1 final is 0, how much is V2 final? In part B, the green ball continues moving after the collision 2.4 meter per second. So if V1 final is 2.4 meter per second, how much is V2 final? Let's check. So we are here. So M1 is 0.5 kilogram. Okay, M2 also 0.5 kilogram. V1 initial is 12 meter per second. V2 initial is 0. Part A, V1 final, if V1 final is 0, how much is V2 final? You are going to see that it is going to be 12 meter per second. And if V1 final is 2.4 meter per second, you will get V2 final to be like 9.6 meter per second. You have to use the original equation, which is M1 V1 initial plus M2 V2 initial equal M1 V1 final plus M2 V2 final. And finally, let's come to question 4. Question 4, a boy on a 2 kilogram skateboard, initially at rest, tosses an 8 kilogram jug of water. Now, the boy is holding the jug. So everything initially, okay, sorry, he tosses the 8 kilogram jug of water in the forward direction. Okay, so everything initially is 0. He is at rest and he is holding the jug, and so everything is 0. I will consider the boy on the 2 kilogram skateboard to be M1, yani the mass of the boy, and the skateboard, which is 2 kilogram, will be considered like M1. And I will consider M2 to be the jug. V1 initial, V2 initial are zeros. Now, if the jug has a speed of 3 meter per second relative to the ground, yani the 8 kilogram, which is M2, Okay. So V2 final is going to be 3 meters per second. Okay, and the boy and the skateboard move in the opposite direction with 0.6 meter per second. In the opposite direction, يعني minus 0.6 meter per second, and this is going to be V1 final. So V1 initial 0, V2 initial 0, V2 final is 3, V1 final is minus 0.6, M2 is 8, and M1 is it 2? No, they won't find the boy's mass. So I will consider M1 to be the boy and the skateboard. Let me find M1 and then I will deduct 2 kilograms from it to get the mass of the boy. Let's see. Okay, so here M1, I will consider M1 to be the boy and the skate. M2 is 8 kilograms, everything initial is 0. V1 final minus 0.6, the boy and the skate go in the opposite direction with this much. And the jug was moving with in the forward direction with 3 meters per second. When you do the calculation, which is, again, everything initial is 0, so you can do simply minus M1 V1 final equal M2 V2 final. So you will get M1 to be like 40 kilograms. Subtract 2 kilograms, which is the mass of the skate, you will get the mass of the boy to be like 38 kilograms. Okay, let me go to one more thing here. Tricky question, for example, from my own. If a block is given an initial velocity of 15 meters per second, okay, so the block is moving with a velocity of 15 meters per second. So this is V1 initial. It enters into a head-on collision with another block of double its mass. Okay, so the mass is not given. So if the mass of the first block is M1, then M2 is going to be 2M1. And 1/3 its speed. So V1 initial was 15 meters per second. So the second mass is moving with 1/3 of this much. 1/3 of 15, so it is going to be 5, but it is in the opposite direction. So then it is -5. The question is, find the speed of the combination of the two masses. They move together, and I have to find the final velocity of both of them. In this case, what I am going to do, M1 V1 initial plus M2 V2 initial is equal to, you know, M1 plus M2 into V final. M1 times V1 initial, which is going to be 15. M2, it is 2 M1, don't forget. V2 initial, it is -5, 1/3 of 15 in the opposite direction, equal to M1 still M1, M2 is 2 M1 into V final, which is unknown. Now, so 15 M1, 2 times -5 is -10 M1. M1 plus 2 M1 is 3 M1, V final. 15 M1 minus 10 M1 is 5 M1, equal to 3 M1 V1 V final. Let me cancel M1 with M1 and divide over 3 over 3. So we are going to get V final to be 1.67 meter per second. So now let's go back to the book. Okay, you are responsible to do the practice here. It is important, and you can, if you have time, please to do extra problems. You have here the section review questions. Okay, but if you can do the practice problems, it's okay. It is very important. Okay. One more thing I want to show you here. Yeah, some MCQ questions. Okay. Question 1 to 4. Look at them, please, and try to answer them. Let me do 1 or 2 with you. Which of the following equations can be used to directly calculate the object's momentum? What did we say? We said that the object momentum is it mass times velocity, or mass over velocity, or force times time? Okay, so it is going to be mass times velocity. Okay, and etc. etc. Questions 5 to 7. Okay, let me check with you number 7. For example, a soccer ball collides with another soccer ball at rest. The total momentum of the balls, is it 0, increases, remains constant, decreases? What did we say? We said that the law of conservation of momentum means the total momentum remains constant, neither created nor destroyed. It stays the same. Total momentum before impulse is going to equal total momentum after the impulse. So the answer remains constant. Okay? And questions 8. Okay? To question 12. Please, okay, try to do these questions. You know, in exams, we are going to give you paper 1 to be like MCQ questions. So you have to practice some MCQ questions. And here, please all, okay, kindly, if you try to check this link. This is a video about conservation of momentum in order to get the concepts completely. Okay, so let me go now to the objectives again. Now, all students, do you know now how to describe the interaction between two objects in terms of change in momentum of each object? Yes, we can describe this. How? We know that total momentum of all objects before impulse is equal to total momentum of all objects after impulse, but momentum of each mass is not necessarily equal to the momentum of the other, and so on. If initially everything was at rest, then this means that one object will go in one direction, the other in the opposite direction, etc. Compare the total momentum of two objects before and after they interact. Okay, so we have to add all momentums of all masses, the momentum of all masses before the interaction, and add total momentum of all masses after the interaction, and we can see, we can observe and recognize that the total momentum will stay the same. Here, so can we state that the law of conservation of momentum? Yes, simply the law of conservation of momentum is saying that the total momentum is neither created nor destroyed. The total momentum of different objects that are interacting with each other before the impulse is equal to the total momentum of these objects after that interaction. And finally, the last objective is to know how to get the final velocity, okay, V1 final or V2 final or V final simply if they are moving together of different objects after they interact. Thank you very much. See you in the next lesson. Bye.